Hello students, welcome to this first lecture on calculus of variations and mechanics. First we consider this overview of this lecture. The first thing we are going to show here is syllabus of this semester regarding this course, then the basic things regarding calculus, the necessary condition of existence of maxima and minima of a function, calculus of variation. In this part I'm going to tell you how the calculus is related to calculus of variations. Then a new terminology, that is the functional, we are going to introduce here. Then how the functional is different from a function. The next thing is extremum. This is unit 1. In unit 1 we'll consider the introduction, then problem of brachistochrone, problem of geodesics, isoparametric problem, variation of its properties, functions and functionals, comparison between notion of extremum of function and a functional, variational problems with fixed boundaries, Euler equation, fundamental lemma of calculus of variations, and certain examples. Then this is your content of unit 2, then content of unit 3. Basically in this course the first 2 units are related to calculus of variations, and this third unit is mainly related to the mechanics part. This unit is related to mechanics. So book reference you will see at the end, the last slide. I have written the main book which you can refer for the first 2 units, and for the third unit I will tell you later. Mainly I can tell you for numerical problems you can consider there is one book of the Sham outline series, Sham outline series. So the second book you can refer, one book is related to calculus of variations. You can have A.S. Gupta, one book, textbook you can refer, and for this another book of the Indian author is G.S. Aruldas. So these are books you can refer for this particular course. And one classical book which is used is, I will write here in the last slide, I will show. Then first, what is calculus? What we deal in the study of calculus. You see, in calculus what we do, we have certain function, that y is a function of x. We can have a function of more than one variable. Suppose u is a function of x, y. It can be a function of more than 2 variables. It can be like u is a function of x, y and z. So what we do here, we study the differentiation of function of 1 variable, function of 2 variables, 3 variables. For function of more than 1 variable, there is a concept of partial derivatives. Right. Now what is the physical significance of the differentiation of a function of 1 variable? You all know. Suppose this is x-axis, origin, y-axis, and if we have a function, we can plot the graph of every function. This is a plot of this function, right? Then if I draw a tangent to this curve at this point P, suppose, and this angle is theta. Then this angle tangent of theta is called the slope. This is called the slope of line. And in fact, in this situation, this line is touching this curve at one point, so this is tangent to the curve. So this is one way. The geometrical definition of slope of a straight line is the tangent of the angle which that line subtend with positive direction of x-axis. This is definition of slope. Now in differential calculus, if I write dy by dx, then it represents the slope of tangent. It represents the slope of tangent to this curve, the slope of this. So in this situation, what happens? This dy by dx in fact is representing tangent of theta, right? Now what happens when theta equal to 0? When theta equal to 0, that means this tangent will subtend angle, this tangent will be parallel to x-axis, either angle 0 or 180 degree. But in that situation, what happened? You see, in fact, you can visualize the situation in this manner. Let x origin and then y. Then situation is like this. The curve may be something like this, y equal to f of x. When theta is 0, that means tangent will be like this. That means in that situation dy by dx equal to 0. That means in this curve, this is the point of minima, and similar situation will happen. If it is there, then it is point of maxima. This is point of maxima and this is point of minima. So maximum and minimum of a function of one variable can be obtained by this condition. Similarly, if we have a function of two variables, suppose u is equal to f of xy, then the necessary condition for existence of maximum or minimum equal to curly u by curly x and curly u over curly y equal to 0. So by solving these equations, we can get the point of maxima or minima for a function of two variables. Geometrically, a function of two variables represents a surface. It represents a surface. And a function of one variable represents a curve. So always keep in your mind. Apart from these things here, in calculus, what we study? In calculus, we study integration of a function. We also study solution of the differential equations. integration of function, solution of differential equations. Now differential equations are also of two types. One is the ordinary differential equation. You simply write ODE, and partial differential equations, PDE. So we also study solution of ordinary and partial differential equations in the branch calculus. Now problem is, here we are studying a function of one variable, two variable, three variable, and maybe n variables. So here these are independent variables, and in this case this is dependent variable. In the similar manner, I told you that the necessary condition for the existence of maxima and minima of a function is dy by dx if it is function of one variable, and for function of two variables it is like this. By solving these two equations you can get the point of maximum minima. For one variable you get point of maximum minima by using this equation and by using this equation. Now in calculus of variations, how this calculus of variation is different from calculus. In calculus of variations we are not having function of one or more variable, but we are having certain other thing, function of function. Later I will call it as functional. So here we find a function. We find a function at which the value of functional is either minimum or maximum. So as in calculus, the differentiation also leads to certain differential equations, and the concept of integration leads to integral equations, and then we find the solution of differential equations or the integral equations. Similarly, in calculus of variations, the study leads to certain differential equations and certain integral equations, but in here we find a function. The solution is not a point, but solution is a function. For example, we take 2 points here, A and B, the very basic problem here, and I can go from point A to B by various paths. Either this way, we can go by this way, we can go by this way, and so on and so forth. I can choose infinite number of paths to visit to this from point A to point B. So now the problem is, there is one path, and you know, each path is nothing but a curve. Now I can go from point A to point B via any of these curves, but there is one curve. Due to which we can travel the shortest path, or you can say there is a curve along which the distance between these 2 points is minimum. obviously for a layman everybody can tell that if we go by a straight line then the distance will be minimum. So it means there are several possibilities of curves, but the solution of having the minimum distance is one, that is a straight line. That means straight line of the form y equal to mx plus c. So the solution is obvious for a layman also, that only statement, but there are various problems in real life, or many physical problems are there where several functions appears in the problems, and we have to obtain one optimum function through which we are getting the minimum value or the maximum value of certain desirable physical aspect. So this is the main thing, how this calculus of variation is different from calculus. Keep in mind two things. One is a function and difference between function and functional, and the next is the extremum. So these are the two concepts which are different from the ordinary calculus. What is a functional? Functional is a function of functions. Functions play a very important role in various branches of study such as analysis, mechanics, geometry, etc. A functional is a function where independent variable is itself a function. Following are some examples of functional. As I told you that this is another problem of that kind. Let A and B be 2 points in the plane, then we can have infinity of paths from A to B. Suppose that particle can move along any of these paths. Let the particle have definite velocity at a point, then we can obtain functional by associating with each path the time that particle takes to traverse that particular path. In fact, this is a problem of determining the minimum time through which that particular particle takes the minimum time to travel. The situation is like this. Here, suppose we are having one point A and another point B. So if this particle in plane with certain velocity travel to this point B by this path, the path can be like this, path can be like this, path can be anything. But here this is not the situation of having the minimum distance as I described earlier, but here is the situation of obtaining the time minimum. The path along which the time is minimum means you want to find the minimum time. So you have to formulate the problem in such a manner so that we can obtain the minimum time. In this case, in fact, what will happen, time will become a function of functions. Time will become a function of functions, and out of those we have to find the optimum functional at which, along which the time is minimum. Time is minimum. Now the second example is related to this can be anything. Arbitrary continuously differentiable function on interval AB, then this kind of formula. There can be any formula depending on the problem. Depending on the mathematical problem arises in various branches of study. It can be in the physics, it can be in the chemistry, it can be in geometry, and anywhere where we desire the optimization of functions. So next thing, you see extremum. In a function you find the maximum or minimum value. You find the maximum or minimum value. But in functionals you find the function along which the value is maximum or minimum. So in the theory of in the calculus of variations, we can find the minimum or maximum function, that is called extremum. Usually in calculus we say point of maxima or minima, but here if we get value of function, that is called extremum. And the problems in which we desire extremum are called variational problems. As I told you, the problem of determining the minimum distance between 2 points, the curve along which the distance between 2 points are minimum. So here you can formulate, the distance, arc length of a curve is given by 1 plus y dash square under root dx, and from a to b. Suppose this is represented by a and this is b. So then any function between this is represented by this, and you have to optimize this length, arc length, along which curve this will be minimum, along what value of y. Y can be x square, means it will be a parabola. If y equal to mx plus c, by solving this thing you get, then y is a straight line, and so on and so forth. So such problems are called variational problems. You can have another problem. You can have another problems like you have a curve between 2 points like this. It can be like this. Then you are revolving this curve about x-axis. Then you have to determine the curve along which, by revolving which you get the maximum area. So this is another variational problem. So this formula will be not of arc but will be of the area. So in this way, you can have many problems in which you desire the study of calculus of variations is necessary. So this is a book, Gelfand IM, Form in SV, and this is one classical book, and I have also referred a book of Indian authors, as I told you earlier. One is of A.S. Gupta, Calculus of Variation, and for mechanics, G. Arul Das, another book is there. So you can see those books. Apart from those books, you can refer my lecture notes or the PPTs, which I will upload on our LMS, Learning Management System, of which link might have been sent to you. So your queries will be taken care of in the live interaction sessions. So that's it for the first lecture. Thank you very much.